Live stream is okay, right? Platelet satellitism, bacterial satellitism rather. So again, I'll try to repeat it for you guys, for the sake of you guys, because I love you guys that much. Wait, somebody posted something on the chat. All right, live stream and then the po. Yeah, I started to make a new one. Kindly double check. But yeah, I'll try to repeat the um, I'll try to repeat the principle of or microorganism cytolytism or bacterial cytolytism. So imagine you started with, let me erase this one again because Adrian is asking me. He's not demanding, but he's asking the repeat of microbial satellitism. All right. So this is your initial inoculum, this bunch of stars here. Wait, it's not being shown clearly in your. Is it being shown clearly in the slideshow there? Ah, yeah, it's not. So I'll try to make a drawing here on this side anyway. Okay, so imagine you have an initial inoculum here. This is your initial inoculum. I'll put a 1 here so we can remember those few dots over there. And then I'm gonna uh, I'm gonna change the color to green. Imagine this is a control streak of Staphylococcus aureus, which is a factor V producing organism. And then the initial inoculum is then subcultured. The initial inoculum uh, is then streaked again to this way. Oops. Initial inoculum is streaked this way, that way. Okay? And you go again this way or that way. Doesn't matter. We just want to demonstrate satellitism. All right. After 24 hours, what would happen is that there will be a growth. There will be a growth near the spaces of the factor V producing organisms. So Haemophilus will be seen, supposed to be green, supposed to be red, will be near the spot of the control organism of factor B producing organism. Okay, so imagine there's colonies here, as a line, a streak of the lines here. Then you did another one here and another one here because you did an uninterrupted streak. So that's how you demonstrate microbial satellitism or bacterial satellitism. All right. So yeah. Okay. So that's how we usually demonstrate satellitism. We can move on to the next one. Um, all right. So differentiate factor A, X, rather factor X and factor V based on heat stability. Heat stability, which one is much more stable? Of course, the one that can survive the heat from making chocolate agar. That's factor X, heat stable, and factor B is much more labile. All right. So that's the only thing that you need to remember. All right, obligate aerobes. Let's talk about obligate aerobes. What do you mean by obligate aerobes? They require CO2. Otherwise, they would not grow on the culture media. All right, they will not grow on the culture media, regardless of how much nutrients there is. If there's no oxygen, if there's no oxygen in the environment, they won't grow. All right, and what enzymes are present in this bacteria? They would have catalase and superoxide dismutase. Right? Catalase is actually one of the tests that we can use to test whether an organism will be speciated or we can find the family of the organism. And we're going to do that when we do a bacterial workup later on. Okay, so examples of bacteria that are obligate aerobes. Our mnemonic here is nagging pests must breathe. All right, nagging pests must breathe. Um, Bacilli. We'll start with letter B because I want everything to be in alphabetical order. Uh, Bacilli, Mycobacterium tuberculosis, Pseudomonas aeruginosa. This is not a typo. All right, this is not a typo. And then N is again nocardia. All right, so they are obligate aerobes. Obligate anaerobes are organisms that require oxygen and that do not require that require the absence of oxygen. Examples of these organisms is can't breathe air. Clostridium, yes. Another one, and another one. O, di ba? Lakas maka DJ Khaled. And another one. What's the other one? Actinomyces. Wonderful. And what actinomyces are we going to talk about? We're not going to be that advanced. Uh, okay, wonderful, because that is for your master. But if you planning to take a master's class, that is the one that you need to study up on. All right? Okay, thank you so much. All right. What is the term given to organisms that require a lesser amount of of oxygen? That is now known as your microaerophiles. All right, microaerophiles, and they require at least 5 to 6% rather of oxygen. And there are certain microaerophilic systems that are being manufactured right now. This is not a commercial, but we're looking at BD. BD, BD is the one that pioneered the microaerophile, the microaerophile systems. Wait, what did I draw? Why did I draw that? Why did I draw this? What it looks like is basically like a candle jar or an anaerobic jar, and I'll show you guys the drawing. I'll try to draw it for you. But basically, you're going to have some sort of jar like this. It does look like a piece of paper, but I'll try to bear with me. All right, there's a lock and key mechanism here. All right, and then inside will be your plates. Okay, imagine this one is your plates. I know it looks like a wallet. Okay, and beside it, you're going to put a packet, which is going to be colored, color would be, I'll try to use color blue because color blue was the color of the packet that I used when I tried to grow a microaerophile. All right, so you put the packet there and it releases maybe 5 to 10% of oxygen in an anaerobic condition. And then after 72 hours, we try to grow the organism 72 hours. And gram-negative curve rods. That's the next thing that you're going to talk about. That's the next question. What organism grows in a microaerophilic condition? That's the answer to this one. That is now known as your Campylobacter species, or Helicobacter is included also. All right, so I made this way back then when the knowledge wasn't enough, but you have to add Helicobacter also. Okay, Helicobacter, specifically H. pylori. Okay, H. pylo. H. pylo na lang, guys. Kasi na hirap na ako magsulat. All right. Okay. So what about capnophilic organisms? Well, there are organisms that require CO2. They are capnophiles. Okay. And the simplest way to they require again 5 to 10% of oxygen, rather CO2 in the system. And one way to traditional way to achieve this is through the use of a candle jar. So imagine the drawing here, and then let me try to just use my, imagine this one, like it's literally a jar, and the lid has rubber on it. And then instead of adding the microaerophilic packet, you're going to put a jar on top. There's gonna be a jar on top tuloy. There's gonna be a candle on top. And the candle's job is to reduce the oxygen because flames burn the oxygen. Flames use off the oxygen, and CO2 would be released in the system, and that will initiate a capnophilic environment for your microbes. Okay, and the capnophilic organism, we have the Hasek organisms. I'm not sure if you're familiar with them. The Hasek bacilli. Hasec bacilli is basically your Haemophilus, Actinomyces, Cardiobacteria, Echinella, and Kingella. All right? So that's your Hasec group. For for your gram-negative microorganisms, you will have Neisseria. Actually, both of these two, let me check. Let me use my highlighter. These two will be commonly isolated in the laboratory. We encountered them several times, and yeah, Echinella, rare, and Actinobacillus is also rare. Cardiobacterium, never in my practice. I have never encountered both of these two. But these two, yeah, they have appeared once in a while, maybe twice in a year, depending whether or not it was an external quality control assurance scheme. But yeah, I've encountered those two, and it's difficult to isolate these organisms. They are considered to be fastidious organisms if we were to sound posh. All right. Now, let's go on with aerobic cultures. What percentage of oxygen is ideal? Of course, the ideal, sorry, discard. Sorry. My slideshow ended. Is everything okay? Adrian, is the live stream still going on? All right, okay. Because I got a notification that it wasn't going on, so that's why I ended the lecture. I ended the slideshow. All right. So it requires 21% oxygen. An aerobic culture, aerobic, not anaerobic. Uh, Aerobic cultures. Let me try to rephrase that so it doesn't sound confusing. Aerobic cultures require what percentage of oxygen ideally? 21% of oxygen is enough, okay? And how much of the following is required by anaerobic cultures? You require 5 to 10% hydrogen. That's why the aerobic systems, they usually have water. When they open them, it's basically dry during the first during the initial stages of the culture and sensitivity test. But when you open the anaerobic jar, they have water on the sides because that's part of the anaerobic system. CO2 is also present around 5 to 10% as well, but the most important thing that is substituted in instead of oxygen is nitrogen. Why? Because there's about 80 to 90% nitrogen present in the anaerobic media, or the anaerobic system. When I talk about the anaerobic system, I'm talking about the anaerobic jar. When I talk about the microaerophilic system, I'm talking about the microaerophilic jar. All right? So as you guys not to be confused. All right? Now, anaerobic jars and containers and bags prevent the accumulation of oxygen with the use of what catalyst? We're using palladium pellets. All right, we use palladium pellets, and the indicator we have resazurin or methyl resazurin and methylene blue. Resazurin is usually colored red in the presence of oxygen, and methylene blue will remain clear. Will remain clear without the presence of oxygen. Okay, so that's the answer to this particular slide. A negative color with remain negative without oxygen, it will remain clear or white. Because in the laboratory, I've experienced using these as controls. They come in as vials or ampules rather of methylene blue, and this methylene blue in the absence of oxygen will remain colorless. And then if it's positive, meaning there's oxygen, it's going to be colored white. Colored blue, hence methylene blue. All right. So please don't forget this. The scientific term for anaerobiosis for anaerobic condition is basically anaerobiosis, and that is indicated by your methylene blue or resazurin. Resazurin, the only difference is that it's colored red. Methylene blue is blue. All right, in the presence of oxygen. Without the presence of oxygen, it will remain clear or colorless, depending on the manufacturer's manufacturer kit that you receive. All right, whether it's an ampule, it could be a paper. Okay. Now, let's talk about psychrophiles. Psychrophilic organisms thrive on colder temperature, specifically around 10 degrees Celsius. And we have cold enrichment mediums, okay? Cold enrichment medium usually is incubated at 0 degrees Celsius, or yeah, nil degrees Celsius here in the Middle East. And the organisms that require this is basically, I mentioned it earlier, if somebody could still recall, which organisms have I mentioned earlier that I considered psychrophiles? Anybody? Psychrophilic, cold-loving organisms. Anybody? Hello? Oh my gosh, am I disconnected? Am I disconnected? Hello? No, I'm not disconnected. No, I'm asking organisms that require cold enrichment or psychrophiles. Uh-huh. And then, nagsabay kasi kayo dalawa. And then, ano pa? What else? All right. Okay, thank you so much. Thank you. Now, psychrophiles, these are the answers to that one, that particular flashcard. Please put a star on this one because this is important. I also put it in bold, so you guys will know that it's important also. Mesophilic organisms thrive and at room temperature to 40 degrees Celsius, probably 20 to 40 degrees Celsius. All right. Most pathologic organisms thrive at room temperature or body temperature. Most pathologic organisms. Um, Anybody in the chat? Room temp? Nakakaloka ka, Cesar? Cesar? Cesar, ha? Cesar. Room temp? Sure? Hunulaan mo lang. Okay, sige. What about Joanna? Most pathologic organisms grow at what temperature or thrive at what temperature? Cool temperature daw, sagot ni AJ. Grabe naman si Mayra, 30 to 70 degrees Celsius. Nakakaloka to si ano. Nakakaloka to si Mayra. Pinatay na niya yung organism. Incinerator si ano. Glag, in-incubate ni ano. In-incubate ni Mayra sa incinerator ang culture media niya. Nako, marirepeat internship tayo dyan sa mga pinagagagawa mo, Mayra. Huwag ganun. Paano kung CSF yan, Mayra, tapos ilagay mo sa incinerator? Napatagalog ako sa iyo, Mayra, ha? I wanted to sound posh pa naman, pero thank you so much, Mayra, for trying to correct yourself. All right. Body temp, yes, correct. Thank you, Joanna. All right. Yeah. Okay. So mesophilic organisms grow at 20 to 40 degrees Celsius, and most pathologic organisms grow at body temperature. But in some books, it's 30 to 30 degrees Celsius. So yeah, let's try to give it a range. In your board exam, you'll probably receive this question not in range, but in specific answers, in specific numbers. So I would opt that you select 37. 37. All right. Optimum pH for the growth of most microorganisms. They grow at either neutral or slightly acidic and slightly alkaline, usually at around 6.5 to 7.5. All right. Now, with the exception of Lactobacillus acidophilus, it will grow at it will grow at the pH of 3, and it's also known as the Doderline bacillus. It's grown in what you call a tomato juice agar. All right? Please don't forget that one, tomato juice agar. Ano bang kaguluhan? Bakit ako nawawala? Ayan. All right. Now, Vibrio is best grown at an alkaline temperature of what? Around 8 to 10. That's the reason why we have alkaline peptone water, all right? Just to create a differential environment for them. All right, so Vibrio will grow at these temperature ranges, but all other Enterobacteriaceae, which is usually found in the stool, will grow at 6.5 to 7.5. And Vibrio will grow only in alkaline peptone water. And we use that one in the laboratory as well. Now, enumerate the growth cycle of a bacteria. This one is important. They asked this in my ACP examination. Lag phase, log phase, stationary phase, and the death phase. So basically, the lag phase is when the organism is present, it's initially inoculated, and then the exponential phase is wherein the organism grows at a maximum rate or grows at an exponential rate, hence the term exponential phase. The stationary phase is wherein the growth ceases because of the fact that the colonial population is almost the same in the nutritional conditions or the nutritional quantity of the agar or the plate or broth that you're growing the organism, and therefore the organisms will stay in that particular phase, hence the term plateau. The last one is the decline phase, wherein metabolites will accumulate, causing the death of the organisms and therefore decreasing the count of the microorganisms present. So each culture media will, prior to, contrary rather to popular belief, that when you put your agar inoculated with organisms, it will overgrow and it will take over the laboratory. It's not the case. Depending on the culture media and the quantity of nutrients that are present in the culture media, that's the time, that's the speed at which the life cycle of the organisms in your particular plate will grow. All right. So please be mindful of that one. Um, I remember when I was in my when I took the ASCP exam, this was the one that was asked of me. Okay, specifically this one, stationary phase. How was this presented as a question? I will tell you. Well, this is the phase of the growth of an organ. Of a culture, what was that, the cycle rather. This is the cycle of the life cycle of of a bacterial organism, within which the amount of organism is equal to the amount of is equal to the quantity of the culture media. And then I realized it's basically a plateau phase, and thankfully I got that answer correct. However, I don't know if at that time, when I was taking the exam, I know the answer. So so looking back on it right now, I think I've answered lag phase. I'm not sure, but I remember that question and then I came back to it looking at, and when I came back to it at my notes, the answer was stationary phase. So please don't make the same mistake as I did. And yeah, all right. Okay, so in the stationary phase, the bacterial growth cycle, what are the probable reasons why the rate of the bacterial multiplication ceases? Uh-huh. Hang on a sec. Stationary phase, yeah. This is the reason why I added this. The nutrients have been exhausted, the toxic metabolites have accumulated, and the development of unfavorable pH. Remember, as the bacteria grows, it will release waste products. These waste products will change or rather alter the environment of the culture media. That's the reason why we have color indicators. We also have so as to observe the changes in the culture media. All right. So these are the reasons why the organism will the organism will reach its peak or rather the plateau. Please be mindful of that one. What are the types of culture media? So we're going to talk specifically about culture media right now. Um, Based on physical state, we have solid, semi-solid, and liquid. The percentage of agar in each is as follows: 2 to 3% agar in solid medium, and 0.5 to 1% in semi-solid medium, and nothing on a liquid medium. All right. So why is this important? Because you might be asked in the board exam, how much of the agar would I need, or the or the how many grams of agar do I need? They will have a calculation question. Some exams, some board exams, they will in the past have asked how much solid medium or how much agar or percentage of the agar do I need. So you need to create a calculation. It has to fall within this range. If it doesn't fall within this range, try again. Try again with the other answer. All right. Okay. So what are the three basic types of liquid medium? So basically, we have a broth, an infusion, and milk medium. All right. I want you guys to take into consideration milk medium because this is usually used in the growth of Brucella organisms. All right, Brucella abortus, militensis, and suis. All right, so milk media. We'll go into that one when we move on to the specific organisms. Infusions, if you remember correctly last week, we have infusions for brain heart infusions for the growth of your for your fungal organisms. All right. Now, most solid media is derived from what extracts of what algae? Red algae. And the common types of solid media is basically your motility media and transport media. Okay? Why is it commonly seen in motility media, specifically sulfide indole motility test medium? Basically, we want the organism to produce streaks on the culture media. And in order for that to happen, we need it to be semi-solid for the organism to move about. Transport media is also required, is also semi-solid for the same reasons, of course. We want the organisms to freely move about so that it can use up the nutrients in the culture media. All right. So there are two types of solid medium. We basically have sorry, we basically have liquefiable and non-liquefiable. And the percentage of agar in each is that a liquefiable agar medium is 2 to 3%, whilst a non-liquefiable culture media is 0%. Why is that so? Because usually these are like the dried up or like lyophilized portions of lyophilized lyophilized culture media, and it's useful in long-term storage of microorganisms. Examples of non-liquefiable solid medium is your chopped meat medium and rice grain medium. Oy, rice grain medium, sir, parang familiar sa akin ah. Which organism grows on rice grain medium? Anybody? Anybody? This is our 100th question. Rice grain medium. Hoy, last week minention mo lang yun, sir ah. Parang familiar sa akin. Parang gusto ko magbigay ng price. Hoy. Parang gusto ko mamigay ng price. Anybody? Alright, I will put 15 seconds on the clock and it starts now. Anybody can answer via chat or okay, I'll put 15 seconds on the clock now. You can begin answering right now whilst I'm giving you guys extra time. Answer by how do we answer? Oh. O tapos, ay, time's up. Sayang. Sayang. Ano ba yan? Sayang. Nakakainis ka, Adrian. Sayang. I want it by voice ha. I don't want it by chat. I don't want it by chat. I want it by voice ha. We want to hear your voices. Wala na. You've disappointed me. You've disappointed me. You've disappointed me. We'll try again next time. Microsporum species is correct. Thank you so much. But in this case it's not agar based. The one for microsporum is agar based. All right. So what are the types of culture media based on composition? So based on composition, we have synthetic medium, we have non-synthetic, and we have tissue medium. All right. Um, Synthetic medium is defined as is a chemically defined medium, and all of its components are known or chemically known. Whilst a non-synthetic medium is also known as your complex medium. This is a medium that has no or that some of the components, so one or more of the components is not chemically known. An example of this is your blood agar media, correct? Blood agar media or blood agar plates. Do you know all of the components of your blood? Of course not. Regardless of how much knowledge we have about the blood, we still don't know some of it. We still don't know some of its composition. All right? Tissue media is used for organisms that cannot grow on cell-free medium. Give me an example of a tissue media. Anybody on the chat? I'll give 15 seconds on the clock. Again, this is another prized question because they were asking me for a second chance. Now, let me repeat the question first before you start answering. Ayan, naulit si timer. All right, 15 seconds on the clock. The question is, give me an example of a tissue medium. This is your clue. Wait, let me minimize this a little bit. This is your clue. These are used for organisms that cannot grow on cell-free medium. 15 seconds on the clock. You remember how to answer the questions for prized questions? You may begin. Anybody? Oh, time's up. Time's up. Ang bagal. Ang bagal. Hala, nasaan ang whites medium? Judges, let's try to ask our judges. Let's try to talk to our peers. Did he get the answer on time? Yeah, see? Mr. Marco said already he didn't get it on time, unfortunately. You are correct. However, Cesar, you didn't have the time. So it should be fast ha, guys. Sir, namamas ko po. Pwedeng ganon. Pwede mo ako sigawan. Alright, Cesar? Alright? Okay. Suspense coming. Actually, the answer would be easy. Eggs. You could use eggs, right? It's actually easy, guys. Easy. You don't need to go to the Google and you don't. I know you will search for it in Google. Uspenska medium, blah blah blah. I know. I've seen that already. Before I will ask these questions, I've already decided. So, Sir Marco is our timing judge, and some of your classmates also timed it. They said that you didn't get it on time, unfortunately. But so try again next time. Sorry. I really want to give out I really want to give out prizes, but unfortunately you have to follow the rules, guys. You realize that I'm strict because of this, not because I don't want to give you guys the prizes, but because in the exams that you're going to take, you have to follow the instructions as well. So it's not because I'm training. It's not only because I don't want to give the prizes. It's not because of some other reason. It's because this is also part of your training to follow instructions properly. All right. We have nothing against you, Cesar. All right. So the most common examples of complex or non-synthetic medium is blood. You can also have plasma or serum, or you can have yeast and plant extracts. Yeast, animal, or plant extracts. All right. So a great example of this is your brain heart infusion, yeast extracts, yeast agars, like that. So those are your examples for um, synthetic medium. A non-synthetic medium. Now, microorganisms that cannot grow on synthetic and non-synthetic medium are as follows. We have chlamydia, rickettsia, and viruses. So I included viruses because they can't grow on media on agar-based medium or non-synthetic medium. Okay, they require cells. These organisms require what? They require cell-based medium. So tissue such as egg, Chlamydia trachomatis is actually traditionally grown on egg-based medium, specifically the whole egg, and then you observe the cytopathic effect of that organ particular of that particular egg. All right. Now let's move on to the most commonly used tissue media in microbiology. We have five actually, and these are cancer cells. Some of them are cancer cells rather. McCoy cells, this is the most popular one. They're derived from mouse fibroblasts. We also have virus cells. Virus cells comes from African green monkey kidney cells. A519 from lung carcinoma. HeLa cells is popular. Please don't forget HeLa cells. These HeLa cells have been used not just for tissue. Oh, sorry. I put an underline on that one. I'm supposed to put an underline. Let's just highlight it. All right. HeLa cells are important because they're derived from cervical carcinoma. HeLa is short for the name of the patient. Let me Google it for a while. I lost my notes. HeLa cells is named after Hela. HeLa cells is named after Henrietta Lacks. It was named after Henrietta Lacks. Her initials Henrietta Lacks. All right. I'll put it on the chat. Okay, the immortal cells of this is one way of immortalizing yourself, actually. Uh, um, donating your cells for the benefit of science. All right, so this is the name of the patient. I lost my notes. I was supposed to have it here with me. It was Henrietta Lacks. I just found out a couple of minutes ago whilst I was eating my lunch. HEP2 cells are laryngeal carcinoma cells. All right, the origins of the name are unknown to me, unfortunately. All right, let's move on to types of media based on dispension. So we have two types of media, and how they are dispensed is as follows. For plated media, you weigh, dissolve, sterilize first, and then dissolve, and then dispense rather. All right, weigh, dissolve, sterilize, and then dispense. For tube media, you have to weigh, dissolve, dispense, and then sterilize. Okay, so I think it is basic common sense. Um, you can't sterilize petri dishes, right? You can't put it in ster. It will boil the agar and it will not appear as a smooth surface. Similar to tube media, you have to dispense it on the tubes, and therefore it would be much more labor intensive if you sterilize it first and then dispense it. It's labor intensive in such a way that risking contaminating the you're risking contaminating the substance inside the culture media inside. So more or less it's common sense. You have to use your common sense in this one. Platelet media, the reason why it's common sense is because when you dispense it first before you sterilize it, the media will not have a smooth surface. All right. On the other hand, if tube media is sterilized first before you dispense it, you risk contaminating the reagents. You risk contaminating the culture media reagents tuloy. All right. Enumerate the types of culture media based on function. We have simple media. We have eight types actually. This is important. Okay. We have simple or basal media, enriched media, enrichment media. We have enrich and enrichment media. We have selective media, differential media, transport media, media for susceptibility testing, and media for biochemical testing. Give me an example of uh, media for susceptibility testing. Anybody in the chat? Media for susceptibility testing. Thank you, Mayra. Thank you. Media for susceptibility testing, MHA. What is MHA? Adrian? All right, thank you so much. Okay, so those are the things that. Give me an example now of media for biochemical testing. Anybody? Joanna, you're in the top people there in the chat. So I just randomly called your name. Joanna, give me an example of biochemical media for testing. Anything that you can remember. Nobody? What about Mayra? Media for media for biochemical testing. Media for biochemical testing. I want to hear your voice, Joanna. All right, mannitol salt agar is actually a differential media, unfortunately. Sorry, selective media pala. Sorry, mannitol salt nga. It means it can only grow halophiles. All right. Sorry, wrong. All right. What about yeah, Rainiel? Give me an example of an agar that is used for biochemical testing. Uh huh. Wonderful, SCA. Thank you so much. And what does it test? Since you've answered already, Rainiel. Siemens citrate agar. it doesn't, and you forgot to test it. Mayra, your answer is incorrect. It's actually a selective media. It grows only one portion of only gram-negative bacilli. It's not it's not a test for it doesn't test the biochemical capabilities of the organism. Unfortunately. Sorry. Motility medium is okay. Yeah. Specifically what? Motility agar. We don't have motility agar. We have blah 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 agar. Come on. Cherise. Your answer, Cherise. What were you saying, Ariniel? Uh-huh. 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 What does it test? Wonderful. From the name itself. Ah, taray. Taray. Wow. I like that one. That is useful. That is very Google. It's very Wikipedia. I love the answer. Thank you so much for going the extra mile for being specific. I love it. Thank you so much. Unfortunately, it wasn't prized, but we'll try again next time when we get a prize. Uh-huh. All right. Now, let's move on to media based on function that is used for supporting the growth of non-fastidious organisms. We have the simple or the basal media. An example of this is nutrient agar and trypticase soy broth. All right. So it doesn't have any specific ounce. It doesn't have any specific elements inside or components. I would say components, not elements. Okay. And they just want to grow generally all organisms, or to be more specific, non-fastidious organisms. When I say non-fastidious organisms, tatagalogin ko na lang, maaarte, kailangan ng extra thing to grow them. Okay, so anything that can grow without any addition of without the addition of specific components, that is a non-fastidious organism. Pag fastidious, maarte. All right? Yun nga yung sinasabi ko kanina, yung HASEC group. Alright, please don't forget the fastidious organisms that I mentioned earlier, the HASEC group. Alright, what are the members of the HASEC group? Haemophilus, Actinobacillus, Kingella, Echinella, and and HASEC, Cardiobacterium pala. Yon. All right? Please don't forget them because they're important in the board exam. Now, let's move on to the media type based on function that supports the growth of fastidious organisms. This is now known as your enriched media. And a great example of this is your blood agar plates and chocolate agar plates. Really, sir? Bakit? Because I've added blood. Blood has different components, regardless of whether or not you know what they are. They're still there to enhance the growth of certain microorganisms. And chocolate agar, as I mentioned before, has what factors? Ulit, has what factors? Mera, what are the factors present in a chocolate agar plate? Reese, sneakers, ano ba? Reese, sneakers ba or ano? What? Factor what? X lang over. X lang, hindi 10. X. Alright, factor V and factor X. Kayo talaga 5 nag-Roman numerals. Yeah, hindi ka nakikinig sa akin. Kanina pa ako factor V, factor X. Nakakaloka kayo talaga. But I love it. I love it. Kanina pa ako factor X ng factor X dito. Ginawang factor 5. Nag-coagulation tayo. Oo, iba yon. Iba yon ha. Kaya ayoko ma-confuse sila, sir. Kaya gusto ko factor X at saka factor V. Alright? Okay. Iba yan. Baka mamaya ginawa ninyong coagulation. O yan na sa specific na ginamit niya. Cherise. Sedhemin na lang. O, di ba? Nababangag na ako, sir. Gusto na ng break? Nababangag. Sorry naman, Mayra. 4 hours to sabi ko sa inyo, you will have my undivided attention this week, di ba? Last week kasi I was going in and out because I was also working in the hospital. Now you will have my undivided attention. Kaya mapupurga kayo sa mga microbiology questions ko. All right. What is the most commonly used blood agar plates, and how is this calculated? Sir, kina-calculate pa? Ano ba yan? Hindi ko na i-calculate para sa inyo. Basta kailangan nyo lang ng 5% defibrinated sheep's blood. Alright? I just want you guys to remember that you need 5% defibrinated sheep's blood. Right? I will give you guys my undivided attention. Kaya nga iniisa-isa ko kayo pagka lumabas ang bagong pangalan sa gilid. Kasi sa group chat may mga lumalabas-labas na ma-attend, ganyan, nagre-raise ng hand. You will have my undivided attention. Hindi katulad ng mga jowa ninyo dyan. Yung mga jowa nyo, pag nag-start ng makipag-usap sa mga friends, they will have divided attention towards you. But for me, since I love you guys so much, you will have my undivided attention. Pero, pupurgahin ko kayo ng microbiology questions. Now, let's move on. Why is human blood not a preferred component for preparing blood agar plates? Remember, I was preparing this when I was still a student, so the grammar is not good. All right. So why is human blood not preferred when preparing blood agar plates? Somebody answered already? Somebody? 17-year-old. Si Sir 17-year-old po eh. Hay nako, tigilan niyo ako diyan sa mga ano na yan, mga unrelated sa microbiology that's not academically related. Ah, all right, wonderful. Whoever said that, Rainiel pala yun. All right, let's continue. Thank you so much, Adrian, for raising your hand. But unfortunately, you were superseded by Sir Rainiel. All right, let's move on to the next question. What are the effects of the following growth? What are the effects of the following in the growth of certain microorganisms? Citrate actually inhibits the growth of streptococcus, while dextrose alters the growth or the hemolytic patterns of microorganisms. What are the three types of hemolytic patterns nga ulit, guys? Please don't forget, we have, I will type it in the chat, binabasa po ni Ursia yung slide. Sino si Ursia? Sorry. Ah, it's okay. It doesn't matter. Again, nagsusumbong sila, no? Nagsusumbong sila as if naman mababago ang perception ko sa mga students. Remember, I entered this. I love it. I love it. Alam mo Sir Marco, I came into this lecture without any expectations. Whether or not they read it, it's okay as long as they participate. Because I believe in kinesthetic learning. The movement of your mouth, the movement of your eyes is actually important for me because that means that if you're participating, you're still remembering some of the thoughts that you've said to me. So yeah, regardless of what you said, regardless whether you found it on Google, you advanced, read the slides, doesn't matter with me. I will not judge you. But the exams will judge your grade. So, doon tayo patay. Alright. Nagsumbong talaga, no? Binabasa mo yun. I love, I love it. Don't worry, wala akong expectations. Or hindi ako naghahanap ng student na ano. Hindi, mas gusto ko pa yung student na walang photographic memory or hindi super genius because they would learn something from me. Do you understand my point, guys? Mas gusto ko pa 'yon. Oo. Yes, yes. Mas gusto ko pa actually yung nagbabasa. Alright? At least kahit papaano na force ko kayong magbasa. Alright. So, okay lang magsumbong. Thank you for making that sumbong-sumbong kay bonggang-bonggang bongbong. Alright, thank you. Alright. Now, what are the three types of hemolytic patterns, guys? Please don't forget these three types of hemolytic patterns. Um, Tingnan nga natin kung sino may stock knowledge niyan kasi matagal-tagal pa to in between the slides. What are the three types of hemolytic patterns? I will call somebody randomly. I will choose number 7. Who's number 7 in our class? 1, 2, 3, 4, 5, 6, 7. Cesar, you are number 7. Lucky number 7. Give me an example of a hemolytic pattern. Person. 7 ulit. 1, 2, 3, 4, 5, 6, 7. Si Sir Marco yon. So we'll move with the next one. Noreen. Noreen. Diyan ka lang. Che, 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 diyan ka lang. Maupo ka lang dyan. Makinig ka habang binubuli ko sila. Diyan ka lang, sir. Noreen. Alpha hemolytic. Alright. Another one. Last one. 1, 2, 3, 4. Babalik tayo sa taas. 6, 7. Alexis, Valerie, and Lirile. Wala. Wala ding picture kaya medyo let's move on to the next person. Anna Jamema Athing. Athing or Athing? I don't know. I don't know if I'm gamma hemolysis. All right. Thank you so much. Thank you for participating. Even if you read it somewhere or you Google search it, it's okay with me as long as you're learning. All right. Blood from what animal is preferred when isolating when isolating species of Haemophilus? Horse blood is of course our preferred one. Again, defibrinated. And what species of Haemophilus is observed what species of Haemophilus is observed to have beta hemolysis on this type of blood? You only have two, Haemophilus influenzae, parahemolyticus rather, sorry, parahemolyticus and hemolyticus. All right, horse blood is the most important one. How do we remember this? I will give you something to ponder on. H starts with Haemophilus. H starts with horse blood. Para influenzae and para hemolyticus and hemolyticus. O, di ba? Para hindi natin makakalimutan. Hemolysis, horse blood, hemolyticus, and parahemolyticus. Di ba? Madaling na malala. Lahat ng H. Don't forget that one. All right? When preparing cap, at what temperature is what would be ideal for to heat the blood? At what temperature would it be ideal to heat the blood? Okay. Um, this is a PAMIT question again. If you're participating, I don't know if some of you guys are will be participating in the PAMIT quiz show, but if you will, it's important for you guys to remember this one because it's a nice to know answer. It's a nice to know question, and it's heated at 80 degrees Celsius, ideally. All right. And CAP is useful for the isolation of the following species. I've mentioned it before, time and time again. Haemophilus, Neisseria, and Streptococcus pyogenes. All right, addition only for Streptococcus pyogenes. Again, why is it important? Why do we need to know these things? Because it was a PAMIT question before. If you're participating, that would be wonderful and that would be lovely if you've remembered this one. All right, what is the media used to enhance the growth of one particular organism? Sir, ano na naman yan? Bakit na naman? We're just going back to the 8 types of culture medias that we have. This one is now what you call the enrichment media. Enrichment media. And we have 3 types actually. We have tetrathionite broth, selenite broth, and alkaline peptone water or APW. Tetrathionite broth is useful for Salmonella shigella. Okay, selenite broth is also used for Salmonella shigella. Okay, they are enriched with the following chemicals, the tathionite and selenite. So both of them can be used for Salmonella and Shigella. All right? And alkaline peptone water, kanino nga siya ginagamit? Alkaline peptone water, halophilic organism. Anybody on the chat, quickly lang, I will choose number 5. Let's call one person from 1, 2, 3, 4, 5. Angel. Angel. Which organism requires an alkaline environment? Hence, you can grow them with alkaline peptone water. Angel, are you there? All right, nobody is answering from on Angel's side. So she's probably in the bathroom or not listening. I don't really care. Let's move on to another. 1, 2, 3, 4, 5. Francis Alipio. Give me an organism that grows in alkaline peptone water. No. Let's move on to another person. One, two, 1, 2, 3, 4, 5. Noreen. Give me an organism that grows in alkaline peptone water. I mentioned it before. Yes, wonderful. Now, what species of Vibrio does not grow on alkaline peptone water? Nakalimutan na niya. Sir, ano po yung alpha prime? We'll talk about that later. I will tell you that one. That is a very good question. We'll talk about that later, and I want you to. And when we discuss about it, please, Charisse, put a star on it because it's a question that was asked in a question bank from the ASCP from the ASCP Board of Certification Exam Test Bank. All right. So, Charisse, yes, I will tell you about it later on because we don't want to get confused. Right now, we're talking about alkaline peptone water, ha? Oh, give me one. Sorry po, nawala po akong boses, Sir Paos. Okay. Carry lang, girl. Alkaline peptone water, Haemophilus tuloy. Vibrio. All right? Now, let's move on to culture media based on function, which is used to grow a particular organism using inhibitors. I've mentioned this before, selective medium. What selective medium did you guys mention before? McConkey agar, right? MAC or McConkey agar. Why is it selective? It is selective for gram-negative organisms. What are the inhibitors present? It has crystal violet, guys. It has crystal violet and bile salts. It prevents the growth of gram-positive organisms, specifically gram-positive cocci. All right? Has crystal violet and bile salts. It prevents the growth of gram-positive organisms. All right? Next, examples of inhibitors in culture media that prevent the growth of bacteria. As I mentioned before, dyes can be used as an inhibitor for gram-positive bacteria. Salts can also be used. Specifically, what kind of salt? Bile salt. What specific bile salt are we talking about? Sodium desoxycholate. All right? Sodium desoxycholate. Now, when we move on to dyes, there are 2 types of dyes. We have crystal violet and gentian violet. All right, crystal violet and gentian violet. These things are added in McConkey agar, making it a selective medium for gram-negative organism. It selects only gram-negative organisms. By definition, a selective agar is an agar or a culture media rather. It's a culture media that allows the growth of a particular organism by using inhibitors. Let's move on. Now, inhibitors used for gram-negative bacteria. What are the types of inhibitors for gram-negative bacteria? So, on one side, we want to prevent the growth of gram-positive bacteria. But on the other hand, we also want to be selective for gram-negative bacteria. And sodium azide and potassium tellurite are examples of the agar used to prevent the growth of gram-negative bacteria. Okay? Now, what are the common examples of selective medium for Mycobacterium tuberculosis? Since we're talking about selective media, there are two types. The most common one is Lowenstein Jensen agar or your LJ agar. All right, Lowenstein Jensen agar or the LJ agar. What is the inhibitor there? Malachite green. All right, I mentioned earlier before, malachite green is a stain used for acid fast bacilli staining, right? Correct? Yes, correct. Now, much granules are also observed when the MTB or Mycobacterium tuberculosis is grown in this selective medium. Much granules. That's the answer to the third bullet. I will show you an example, the appearance of LJ agar. Actually, this is the one that I saw when we were growing LJ media. When we were growing MTB in the laboratory before. So, ginugol search ko lang siya, pero usually ganito din itsura niya. Tube medium siya. Sir, akala ko ba tube media is only for liquid media? No, it's not used for liquid media. It could be used for solid media as well. We didn't say anything. And the brand is Thermoscientific. Yes, correct one. All right. So that is the appearance, the cauliflower colored colonies. All right. If you want to see, yeah, I Google search it, but it's the same one. It's literally the same thing. It grows literally. It's literally the same thing when you see it in person. All right. Now let's move on to the next one. Lowenstein Jensen agar, the inhibitor is malachite green. Why did I show you that picture? It's because the color of the agar is green. So you won't forget the appearance of you won't forget the inhibitor. All right? And then you can see much granules when you stain the organism. All right. Selective media for Corynebacterium diphtheriae, we have your Muller's tellurite agar. Muller's tellurite agar. Now, Corynebacterium is what? Gram positive or gram negative? Since we're using tellurite or potassium tellurite, which means we're inhibiting the growth of gram-negative organism, and therefore Corynine bacterium is therefore Corynine bacterium is gram-positive or gram-negative. Anybody in the chat? I will select number. I will ask, ha? Ewan ko, pagod na. Oo, pagod na. Wala kasing motivation, sir, eh. Wala kasing motivation, eh. Um, let's try with number 2. 1, 2. Adrian, what is the gram stain reaction your of Coryn and Bacterium diphtheriae? All right, wonderful. Thank you. O, di ba inaantok na nga Sir Marco? Selective mean. Makulimlim ba dyan? Malamig ba dyan sa Philippines? Dito kasi ang lamig dito. My goodness, winter na. Naka-heater ako. Umuulan. Okay. Anong oras na ba ngayon? Yeah. Malapit na pala tayong matapos. We have 37. We have 30 minutes na lang pala. More than 30 minutes pala. Okay. So, we're gonna end the discussion after we finish the agars. Don't worry. Or the culture media, rather. So, what is the selective media used for Neisseria gonorrhoeae? Please don't forget Thayer Martin. That's the most important one. Martin Lewis is, yeah, uncommonly asked, and a modified Thayer Martin in New York City agar is basically the things that are selective for Neisseria gonorrhoeae only. All right, and the selective differential medium, it's a combination of both, the, that is used for Staphylococcus is MSA, mannitol salt agar. Contents, we have sugar, which is your mannitol. The inhibitor is 7.5% NaCl, meaning that this organism is a what? A halophile. And the pH indicator is phenol red. All right? In MSA, how is a mannitol fermenter differentiated from a mannitol fermenter? Well, basically, we're going to talk about Staphylococcus aureus. So, Staphylococcus aureus will produce yellow colonies, all right? And pink colonies will be observed with other mannitol non-fermenters, including your Staph epidermidis and Staph saprophyticus. In this case, you can start a workup, okay? You can start your, if you isolated something in mannitol salt agar, you will definitely grow something like, you will definitely grow Staph species. So imagine this is your organism. It grows, it's yellow, and it grows as Staph aureus. But you're not sure if it's Staph aureus, so you plant it on, it's gram positive by the way. These are yellow colonies on blood agar. So you plant it on mannitol salt agar or MSA. MSA yields two things, mannitol fermenter and mannitol non-fermenter. Okay, this is how we usually do it before when I was working in the Philippines. If it's a mannitol fermenter, most definitely, then that would be with beta hemolysis. Where's my highlighter? What happened to my highlighter? If it's a mannitol fermenter, most definitely, nasa na yung aking highlight? Hala, nawala. If it's a mannitol fermenter, let's use a highlighter na lang. If it's a mannitol fermenter, most definitely that's Staph aureus. Okay? Why? Beta hemolysis, isolated in in probably the skin, the throat, or blah blah blah. Okay? If it's a non-mannitol fermenter, it's only one of two things. It's either Staph epidermidis and Staph saprophyticus, SSP. That's our shortcut when I was working there in the Philippines. Now, how do we differentiate these two? We use novobiosine test. Okay? Novobiosine. One is positive, one is negative. All right? So that's why I always present them in this particular order so I don't forget which one is positive, which one is negative, because I have such a dyslexic mind that I oftentimes forget the reaction, whether or not it's positive or whether or not it's negative. All right? So I always remember them as psi. I say SAS. What says? SAES. Staph aureus, epidermidis, and saprophyticus. So that when I'm in the exam, it's easy for me to remember the workup. All right. So please don't forget that one. That is again another must-know information when you are going to take your board exam. Now, how do we differentiate the two mannitol from non-fermenters? You will differentiate them with novobiosine resistance test. And one is sensitive and one is resistant. One is positive for sensitivity, one is negative for sensitivity. All right? So that's how I always remember them. Novobiosine test. Okay? Now, selective differential media for Vibrio species. I've already mentioned it, thiosulfate, bile salt sucrose, or TCBS. The pH indicator is your bromthymol blue. Bromthymol blue. Sir, bakit kasi nung nag-intern ako, color green siya? Well, bromthymol blue is actually green in an alkaline, in an alkaline environment. However, because when your organism is present, it will become it will become blue. Okay, when the organism that we want to be selective for is blue. Blue. Other organisms aside from Vibrio cholerae would produce a blue color or greenish color, except for Vibrio cholerae, which will produce yellow colonies. All right, we'll talk about more of that later when we move on to microorganisms, or maybe next week. All right, in TCBS, colonial appearance of a sucrose fermenter, Vibrio cholerae and Vibrio cholerae will produce yellow colonies, and non-sucrose fermenters such as parahemolyticus will produce green or blue colonies. All right. Selective differential medium from gram-positive and gram-positive enteric medium. Enteric, which means stool. We're using stools as our sample, or gastric juices, or we can use also. What else can we use? Yeah, stool, gastric juices, duodenal fluid if you want to be much more specific. But in this case, you have four differential medium for gram-negative enteric bacteria. You have EMB, eosine methylene blue, McConkey agar or MAC. HEA is hectoine enteric broth or hectoine enteric agar. It can come in a broth form. SSA is Salmonella shigella agar, right? So they might ask you a question, which of the following is not used for the growth of gram-negative enteric bacteria or gram-negative enteric bacilli? They will give you this -1, and then they will add something to confuse you. That's the one that you have to select. All right. Now, transport media. We're talking about transport media this time. Again, lalabas dyan si Amy's medium, Carrie, Blair, Stewart, and Transgrow medium. All of them are semi-solid because what did I mention before? We want the organism to move about the medium. We want the organism to move about the medium so it can utilize most of the nutrients present in the medium. We don't want it on solid. We don't want it solid. Why? If it's solid, it means that the organism can't move about, and therefore we will have a lower colony count. Okay, we will have lower numbers of colony forming units, or CFU. Okay, what component of transport mediums absorbs fatty acids and toxic substances from the sample? It's actually charcoal. A lot of the culture media that we have, they have charcoal present in them, whether it's added or whether it is carbon carbon charcoal, or I forgot the term for that one, but it's the colorless form of charcoal. All right. So that will be the end of our discussion. We'll next talk about the susceptibility testing. The lectures will be available for you guys in my YouTube channel. I specifically created a playlist for you, and any other medical technology related questions that I might be doing will also be posted there. Hopefully, you go and visit it if you have time. And yeah, I hope to see you guys next week. But we still have time, right? Yeah, how many minutes do I have? I don't have 25. I still have 25 minutes. Can we have a 10-minute break and then we'll play the Kahoot game again, right? All right, we'll play the Kahoot. So you guys are familiar with my previous directions, right? You're familiar before pictures. Oh, okay. So I'll tell you guys the directions. I'll present the. You guys will visit the Kahoot website. Kahoot, Kahoot website. Wait, hang on a sec. Play Kahoot dot I oh that IT pala that Kahoot dot IT. I'm not sure if that's the correct one. Yeah, you're going to visit the website. This one. Don't worry, it doesn't have virus. It doesn't have a virus. Oh yeah. Okay, thank you, Adrian, for posting it for me. And then I'm going to give you guys the game pin. But I'll give you guys 10 minutes to maybe review your virology notes. 10 minutes. And then after 10 minutes, we're going to start accepting people in the game. All right. Oh, I forgot to end the live stream. So next week's lecture will be susceptibility testing and the specific organisms. But for now, we're going to have a break, games, and also don't forget, whoever gets the highest three scores will have it will have a cumulative effect. So at the end of my lectures here in capital medical colleges. You will add all your scores, and the one who has the highest scores will have a prize. The prize will be announced on my birthday, of course. Okay? Clear? All right? All right. Noted. So yesterday, the highest scoring student was, let me check the paint, Adrian. Adrian, Mayra, and who else was that? I have it in paint. Oh, I wasn't able to save it. Ah, yeah, first leg of the competition. Yeah, this one. These are the people who got places. So next week will be added, the scores for this week will be added, and then next week, and then it will all be cumulative. And at the end of the competition, the one with the highest one get the will get the prize. And mind you, that is a very high yielding prize. High yielding then, parang exam then. All right. So yeah, 10 minutes on the clock to prepare. You guys have time to check out your virology notes, but I will not announce what is the topic of the questions, because I don't want you guys to have an idea of what to look for. But you guys have time to browse your notes. All right? Or let's give you guys 15 minutes. Baka sabihin nyo napakasama ako eh. No? 15 minutes. Paltan natin. Baka sabihin nyo napakasama ako. Walang nanalo ngayon sa ano eh. Walang nanalo ngayon, so medyo idadagdag na lang natin dun sa price ng mananalo. All right? Okay, everybody is ready? No, no, not. Everybody is clear with my instructions pala. Everybody is clear with my instructions. Nobody is answering us.